Alright guys, we are going to do a little bit of pre-labbing because we want to get started, hit the ground running on our magnesium oxide Hess's Law lab. So what we're going to do is, you know that Hess's Law is essentially saying that state functions are going, it doesn't matter how you get there as long as you keep track of where you get. So what we're going to do is we're going to take magnesium and we are going to add it to hydrochloric acid, and it is going to make magnesium chloride. Okay, hydrogen gas. Let's go ahead and balance that. You can add state symbols later. And we're also going to do the same thing with magnesium oxide. And we're going to add it to hydrochloric acid, and it's going to make magnesium chloride. And one. Let's go ahead and balance that one too. Now, you can see that some things are staying the same, some things are changing. So look, here we have magnesium oxide, and then we have magnesium chloride that they both have in common. So what you can do is apply a little bit of Hess's Law here, and we can draw an energy cycle. With that Hess's Law, you can then kind of add the two of them together. This one has a delta H value, this one has a delta H value. And if you flip your reactions, you could probably try to find, the goal is to find magnesium plus oxygen. We want to find the enthalpy of formation of magnesium oxide. Okay? So essentially we're going to measure two things, H1 and H2, and we're going to find the enthalpy of formation of magnesium oxide. Pretty awesome, correct? Yeah, go ahead and balance that one too. Now, another way to visualize that is an energy cycle. We had magnesium. You know you're going to have magnesium, and we have magnesium oxide. And you can also think of our common product was going to be magnesium chloride, right? Now you can, going from magnesium to magnesium chloride, that took some HCl, right? And then going from magnesium oxide to magnesium chloride, that took some HCl. And we can find out magnesium to magnesium oxide, and that's going to take some oxygen, right? So you have seen this before. If you have the delta, this is our delta HF, and if we find out delta H of 1 and then delta H of 2, hold on, did I get those backwards? I did get those backwards. Let's get the numbers right, consistent. If this is delta H of 1, and this is delta H of 2. What you find is you get clockwise arrows equals counterclockwise arrows, right? So here we have the clockwise arrows here. The green arrows will equal the blue arrows. So delta HF plus delta H1 will equal HF, H2. So we have to measure delta H1 and delta H2. Okay, so that covers probably the first question and the second question of your pre-lab. And then then you'll have to construct a data table for this. So let's think about what we're gonna have to do for this. Now, when we have a data table, this is gonna be a calorimetry experiment. So remember, in a calorimeter, you'll have, I mean, you guys are pretty familiar with this type of experiment. You have your styrofoam cup, and you're gonna put your acid in here. So this is your acid. That's gonna be your HCl. You're gonna have your thermometer here. Thermometer here. So you're going to measure the initial temperature of the acid and the final temperature of the acid. Now remember that you'll have to the graph of the temperature over time is going to look like that. So remember, you will have to compensate for heat loss when you do that. Now, also you'll have to find the mass of the HCl. Okay, and we're going to assume that the specific heat of HCl is 4.18 joules per grams degree Celsius. Okay, so we'll have to do that. And we will also need to know, let's see, oh wait. And we'll also have to know the mass of our magnesium. This is for that first magnesium equation. That's because we want to know, that will take us to know the number of moles of magnesium. All right, so data points you'll have to collect are initial temperature, final temperature, the mass of the acid, you know the specific heat, and you'll have to find the mass of the magnesium, okay, because you're going to have to find the moles of magnesium to find the kilojoules per mole. And then you'll have to do the same thing for, and that's just for magnesium. Then you'll have to do it again, and I want y'all to do the same thing. You'll have to find the initial temperature, final temperature, the mass of the HCl, the specific heat of HCl, and then also the mass of your magnesium oxide, which will take you to the moles of magnesium oxide. Okay. So 5 data points on each side. Now, ideally, we would run 2 trials. So try to buddy up with a partner. One of you can run one trial and the other one can run another trial. Or one of you can run magnesium and the other one can run magnesium oxide. We'll try to do that and make it as good as possible. That will help us work things out. Now, we also have to worry about error propagation. So the decimal place is going to give you, it's going to give you plus or minus 0.1 on this one. So you have to worry about sig figs on your temperature, 0.1. So your mass, why don't we I don't think we need to do the analytical balance. So let's use the 0.01 balance, and let's use 0.01 balance here. So make sure we can keep track of our error here, plus or minus 0.1, and plus or minus 0.1, 0.01. That one will have sig figs, plus or minus 0.01. Okay, so be ready for error propagation, be ready for data collection, make a data table. You can make it in a computer, or you can make it, scratch it out on a piece of paper and then put it in the computer. That is probably the best way to go. All right, so that's it for the pre-lab. Thank you.